So starting chapter 3, pairs of lines and angles. What does it mean when two lines are parallel, intersecting, coincidental, or skew? Now we talked about some of those last chapter, some of the skew stuff, but I want you to complete example or exploration 1. Take about a minute or so working with your groupies. Come up with the names of those lines there. Sorry, not the names of the lines, but the number of points of intersections of those lines. Okay, what do you think for A? How many points of intersection? 0. The parallel lines, they never intersect. How about intersecting lines? 1. Okay, and coincidental? Infinitely many. Now, coincidental means, or coincident, okay, those mean they're the exact same line. They're lying on top of each other. So, infinitely many. You draw a line. You can label it with 2 equations. All right, let's go ahead and try exploration 2. Work with your groupies there. Be a little longer. Okay, go ahead and put your classification reason up there. See how you do.
I'm just here because I know y'all need pencils, so I'll give you pencils in the back.
Sure, because they didn't ask you for what? For the pencil.
I'm not sure you get that.
What? They didn't ask you for one. I would choose a season.
Y'all got your own pencil? No. Almost there. Try to steal it again. Oh yeah, take that. Dude, I'm still not going to get it taken forward. You broke the tape. Yeah, alright. Well, I broke the tape. I'm broke. It was already broken. It's like telling someone you're breaking up with them after you already broke up on it. Yeah. Have you done it before? Yeah. It is very tight. I'm on music girl. She's like, oh my god, again? It's sad for hey, no, don't do that. Don't do that. Boy. Do the other one too now. No. Whoa, oh. Mr. McCoy. Straight up bar. I'm not sure you do this one. I'm not going to do that one. You can do that. You have a pencil.
All right, let's see how we did. Got all but one of them up there. So AB, BC are intersecting. They cross at one point. All right. What point do they cross at? Point B. Okay, that'd be the point. All right. And AD and BC are parallel. They never intersect. Okay. Okay, one thing we may want to put here is they do not intersect in the same, what? Same plane. Yeah, because if they don't intersect, but they're in opposite or in different planes, what do we call them? Take out your earbud, please. Call them skew lines. Good. EI and IH are coincidental because they're the same line. BF and EH are skew lines. They do not intersect and are not parallel. Very good. And EF and CG, what are they? Good. EF would go from there to there, and CG is right here to here. Those are skew. Okay? And we can use the same reasoning. They do not intersect, but they aren't parallel. Or they are not in the they do not intersect and they are not in the same plane. Okay, and AB and GH are actually, switch that up here. AB and GH. Where's GH? Thank you. AB and GH, those are parallel. Okay? They're parallel because this line and this line, you could draw a plane that connects those. It would be kind of that diagonal looking plane there. Okay, in the middle. Since they're in the same plane and they never intersect, they are parallel lines. So the difference between parallel and skew lines. Skew lines cannot have a plane. So these two, they do not have a plane that will contain both lines, whereas parallel lines do have a plane that would contain. All right. Questions? I think you got it? Some good vocab there. Okay? All right. Switch it over. Exploration 3, identify all pairs of vertical angles. Explain your reasoning. All the linear pairs of angles. Explain your reasoning. Off you go. By the way, hey, one new vocab term. This is called a transversal. A line that intersects two other lines. And in this case, intersecting the parallel lines is called a transversal. Okay?
Wait, what is it?
Okay, let's see how you did on the first one there. Okay? Angles 1 and 3, 2 and 4, 5 and 7, 6 and 8 are all vertical angles. Because two pairs of opposite rays are formed by each of these pairs of angles. So when you're looking at vertical angles, this guy and this guy, they intersect right here. Okay? Those two lines intersect there, and they form opposite rays from that point. Okay? Those are vertical angles. Some of you just say, well, they're diagonally opposite of each other when they intersect. Okay? Linear pairs. Linear pairs form a straight line. 1 and 2 form a straight line. They make 180. 5 and 6. 4 and 3. 8 and 7. 1 and 4. 2 and 3. 5 and 8. 6 and 7. Okay? One pair of opposite rays is formed by each of these pairs of angles. So think of it this way. They make a straight line. They make 180 degrees. That's what a linear pair does. Okay, so that's kind of a review of those terms. We're going to use those today when we're dealing with parallel lines and transversals. All right? I want you to switch over to page 67 real quick. Now on page 67, I want you to draw that diagram. Okay? Using that diagram, we're going to actually define these things right here. Skew lines and parallel lines, we've covered, oops, not parallel planes. I shouldn't have marked that one. Okay, so we won't do that one. But these guys here, parallel planes, planes that never intersect, skew lines and parallel lines, we talked about those. You can draw some examples, maybe use exploration number 2 for help in drawing examples there. Okay, but I really want to focus in on this diagram and these 5 terms. Okay? No? What's my transversal? What line there? Line P. Line P is the transversal. It intersects two parallel lines. When we talk about transversal, we're generally talking about a line that intersects two parallel lines. Okay? Or a set of parallel lines. Corresponding angles. Corresponding angles are angles that, like if I were to cut out this chunk right here, this chunk of 4 angles, and then move it so that it lies right on top of this chunk of 4 angles, which angle from up here would match up with the angle down there? Which angle from up here would match up with angle 5? Angle 1. So 1 and 5 are corresponding. Okay? And corresponding angles with parallel lines are congruent. Now make sure you stipulate that the lines have to be parallel. Corresponding angles with parallel lines are congruent. They're equal. Okay, so angle 1 and angle 5. Angle, what's another set? 2 and 6. Tell your neighbor another set. 3 and 7, and
But what if they're not parallel
4 and 8.
lines?
Well, if they're not parallel lines, then we cannot say that they're congruent. We can just say that they're corresponding. So that's a good question. If these lines are not parallel, then the angles aren't congruent. All they are corresponding. They just, I mean, they're in the same spot. So if you think of this as like 4 seats on a ride, okay, well, right now the lines are parallel, therefore the seats are exactly the same. However, if the lines weren't parallel, the seats wouldn't be the same. They'd be in the same position, just not the same size. Okay? Alternate interior angles. Okay? Alternate interior angles, once again, happen. All these things happen along a transversal, so they always have to have the transversal connecting them in order for these things to work. Okay? Alternate interior angles happen on alternating sides of the transversal and on the interior of the lines. So alternating sides on the inside would be, what do you guys think? 6 and, not 2. 6 and 3. Okay, this one and this one are alternate interior. They're alternating sides of the transversal, but in between your parallel lines. So you have to think, well, the parallel lines are sandwiching those things in between. Okay? They're inside them. Alternate interior. Okay, so 6 and 3, and in this case, angle 6 is congruent to angle 3. So once again, they're with parallel lines. They are congruent. Okay, what's another set? 4 and 5. All right, alternate exterior. So alternate interior happen inside the parallel lines on opposite sides of the transversal. Alternate exterior happens outside the parallel lines, but on alternating sides of the transversal. So for instance, which ones? 2 and 7. What else? 1 and 8. Okay, and once again, with parallel lines, they are congruent. It'd be nice to have a symbol for parallel lines. Maybe we'll have to use one for the next one here. Consecutive interior angles, also known as, you'll see this rather than consecutive, I use the term same side interior angles. You're going to see that a lot as well. Same side interior angles or consecutive interior angles mean the same thing. So they're on the same side of the transversal and inside the parallel lines. So which of those are on the same side of the transversal but on the inside of parallel lines? 4 and 6. Angle 4 plus, so the measure of angle 4 plus the measure of angle 6 equals 180 degrees. Same side interior angles with parallel lines, and I'm going to use this symbol for parallel. Add to 180 degrees. They are supplementary. Okay, what other ones are same side interior? 5 and 3. We don't actually talk about same side exterior, but what could we say about same side exterior? You guys could come up with a theorem about same side exterior. We're not going to actually state it, but same side exterior, let you guys think about that there. Okay, questions? All right, you guys look pumped. So Okay, so let's look at example 1 from the textbook. Okay, for those of you that want to have the top part there it is. But okay, work with your groupies. Answer questions A through D. Okay, how many have the first one? A, lines parallel to CD containing point A. Tell your neighbor what you got. Parallel to CD but contains point A. How about AB? Make sure you put the correct symbol. It's a line. We're dealing with line. I guess you could call it, they're saying the line, so we would want to actually put the arrows on. If they said segment, you could leave the arrows off. How about B? Line skew to CD containing point A. AH? Anything else? AG? Okay. AH or AG? Okay. How about, and that's just lines I show, right? So there are other lines we could draw in, like A, E would work, and we could put a bunch of them, but just based on the lines they show. Okay. Lines perpendicular to CD and containing point A. Looks like A what? D. And planes parallel to E. Remember, you need 3 points to define a plane. E, F, G, so we're talking about the bottom. And containing point A. Yeah, that'd be the top plane, right? So pick 3 points on that plane and let's name it. Plane CDA, or ABC, or BCD. Okay? Why not? So if we say BCD, does that contain point A? It still does. It's just the name doesn't, right? Okay. Very good. Any questions there? All right. Let's take a look at these two postulates. I want you to read them to yourself. See if it's anything amazing that jumps out at you. You're like, whoa, I didn't know. Okay, was there anything you didn't know? Maddie?
On the 3.2, it says there's exactly one line through P and perpendicular to L.
Yeah, you didn't know that.
Why though? Like, why is that?
Well, there's no other way to draw a line through this point and make it perpendicular to that. Like if you, you could try it, right? If you took like a corner of a piece of paper, started going, okay, so I go that way. Well, if I go like that, that's not going to be perpendicular. See what I mean? Mm-hmm. So, yeah, pretty cool. All right, let's move on past the coolness. Okay, example 2. There we go. I know, so much coolness in one period. It's just unbelievable. There we go. Get a couple minutes there. Groupie. Okay, could I state any other lines parallel? The only ones with parallel markings are EF and MD. However, some of you would look at like CE and BF and go, well, those look parallel, but unless we have these little symbols right here, we can't show that they're parallel. You have to have those markings. Yeah, Alex? We're going to call them lines. Yep. Especially because they're asking for parallel lines. Okay. Name a pair of perpendicular lines. How about MD and? So MD, we're going to use the perpendicular symbol. It's upside down T and BF. Notice we have that right angle marking right here. Okay. That gives us MD right here and BF. Yeah, KJ. MD. MD. Yeah, well, it'd actually be, that would be a ray. That's for sure. Yeah, that would actually be ray DM. Thank you for pointing that out. The way they have it labeled up there, that'd be ray DM. perpendicular to BF. Hey, that's a good call. Well done. I owe you a dum-dum. Good. Okay, explain, or is FE parallel to AC? Nope, FE is not parallel to AC because MD is parallel to FE, and by the parallel postulate, there's exactly one line parallel to FE through point M. Okay? FE is not parallel to AC. And some of you just would go, well, if you continue AC out, you're going to intersect way out here somewhere. Right? Yeah. Yeah, in this picture, they don't have the markings to indicate it either. Yeah. Okay. How do you think you got it? Okay, tell your neighbor what's different about these pictures of alternate interior, same side interior or consecutive interior, and corresponding angles and alternate exterior from the ones that you've already defined. What's the difference? What's the big idea, man? Get it, the book, big idea? Come on. Okay, what's different? Nathan? Yeah, the lines aren't parallel. You guys, you can still have these same type of angle corresponding, same or alternate interior, alternate exterior, and same side or course consecutive without being parallel. It just means these are not congruent. These are not congruent. These are not congruent, and these do not add up to 180. Okay? So just make sure you understand, like, look, if they're parallel, then they have special properties. If they're not, then they just have names. That's what we call them. Okay? So, class 5, come up with some names there. Hey, let's see how you did. Any of those would work. Actually, it says identify all. That's a lot of them. Okay, ladies and gentlemen, your assignment today is going to be your student journal, page 70. Page 70. Okay? Student journal, page 70.
Wait.
Okay? Oh, there you go. You guys will get back your tests tomorrow. They're in the grade book, though, if you'd like to look at them. For those of you who got below an 80%, remember you can do the alternative assessment at lunch or before school. Okay? Yes? No, the line design's for your benefit, man. Amazing fun. Good job today.